Good afternoon, sir. Afternoon, Asia.
Afternoon.
Hi, Asia and Mikey. I heard you guys, but I couldn't unmute at the time. What go on? How things?
And things are okay on my end, sir. So I feel
Uh,
better now.
I'm not 100%, but I'm about 80%.
Alright,
I'm giving
that's
thanks. Still have a cough, but I'm not gonna let that keep me down. All right, hold on a minute, please.
Evening, guys.
even.
Good afternoon, sir, Pods. Evening starts at 6 o'clock. Asia, may I ask you a question? You have an issue with the rounding off with Edicosaf?
Nope.
All right, so my issue is this, you know. The thing is correct, but
Which topic you talk to? Unit 1 or unit?
unit 2.
Mm.
Yeah. So the answer correct, you know, but some of the answer them want it round off to 1 decimal point, the others them want it to 2. Me confused. It's either 1 or 2.
I mean, whichever the question answer. No?
No, in the answer that, you know, but when you go to the solution, that what it say. That my local issue I have with it. But I'm gonna try to figure it out. Or I'm gonna send you something right now. Type your email address in the chat. Quick, Asia. I'm gonna send you something right now. You don't have to send the Excel one. You can send a personal email.
All right. So yes, Mikey, you just have to go work with it here. Sometimes them say 1, sometimes them say 2. So it's just so it go.
So it confusing bad enough because it make you doubt yourself when you see the big X come up, you know.
No, man. No, don't doubt yourself, man. Don't doubt yourself. One of the things that they don't want you to do is round off to a whole number. Once you get to decimal, you can just go ahead. And sometimes when you're entering the stuff, you know, when you're entering on, hold on a minute, please. Hold on a minute, please. All right, sorry about that. Yeah. So, all right, so I need to eject this thing because it's giving me quite a bit of feedback. So let me just eject it. Oh no. No, I can't. I don't want to eject. All right, so I thought I was sharing something actually because interesting. I actually had it up. All right, so we have completed looking at the probability distribution. To my mind, how do I assess it? I think the last class we had, the last class, sorry about that. The last class we had, we were able to clear up some of the issues that we had in terms of reading the double inequalities. And I think once we clear that up, the questions became easier. I am moving into another area. And hear me out. This other area is another must-have. It's an area where every statistics exam you go into, there's a question on linear regression and correlation. If you don't believe me, grab any stats paper. There's always a question on linear regression and correlation. Matter of fact, let me just give you some background to this because we're starting this today and I'm going to see how far I can get to. If you're comparing two phenomena and you have data on each, this is the method that you'll do a fantastic comparison. Your linear regression, your correlation, how it is that one variable operates or behaves when compared to another variable. So I would have used this to look at students' performance in math class, the time students spend on their assessment compared to the grades that they get. The grades that students get on their assessment compared to the number of times students come to class. So it is a comparison really of two variables, and the comparisons yield quite a bit of information, right? So the learning outcomes, as you refer to your syllabus, says by the end of this unit, you'll be able to explain terminologies used in linear regression and correlation. You should be able to plot a scatter diagram of bivariate data. Bivariate data means two sets of data, right? You're normally comparing two things, as I said at the start, right? Your bivariate data. So you may compare rainfall and the inches of water or the runoff rate. You may compare days versus rainfall. You may compare land slippage with rainfall. So you're actually comparing two sets of data. You're comparing two sets of data, which is why it says bivariate data. Then we're going to be asked to calculate the slope and intercept using the least square method. Then we're going to determine the least square equation. And then now the big shots here now is to calculate the product moment correlation coefficient and to calculate and interpret the coefficient of determination. So what you're going to be required to do is do some interpretation of your results. That will inform some decisions. If I could find that report. I'm going to see if I can find a report and share with you before I get into this. So the content is that we need to define linear regression and correlation. We need to look at scatter diagrams, slope, least square method, and so we need to look at the line of best fit, and we need to talk about some stuff here. But give me half a second. Let me see if I can find me a report I did. Send. uh, uh, I never thought of it, you know, I said I've looked for it from before. This was, wow, January 23, 2023. That's so long I did it. I had done, let me see if I can. All right. All right, so I found the report. So let me, I'm just going to show you a report that I did even before we start doing any calculation. New share, pass rate, I think that's the name of it. You seen something that says Department of Mathematics?
Yes, sir.
All right,
And
so
effectiveness.
right, so the institution, your institution, the ECC, is going up for institutional accreditation. So you all know that your associate degree is accredited by the University Council of Jamaica. Your bachelor's is not yet accredited, but it is in progress. So what is happening with the bachelor's now is there's no more programmatic accreditation, because we have received candidacy for institutional accreditation. It means that any program being offered by the institution would be accredited. All right. So we decided not to do the programmatic accreditation for the bachelor's. We'll just wait for the institutional accreditation. So this documentation that I'm showing you is something that we have to send to the UCJ as it relates to mathematics and the interventions that we have to use for those persons who did not pass CXC math and came in to the college to start their program, any course, the associate degree in environmental studies, math and finance, whatever it is, and they have to do foundation concept in math. So, you know, I said that some students entering the college to pursue a bachelor's degree without CSEC math in general certificate GCE or general certificate GCSE math, you know, as a result of that, we'll have to do foundation concept 1, 2, and 3 to assist students in attaining the necessary skills required to pursue higher level mathematics courses like what you are doing now. While the traditional methods of teaching and learning have had some success in Jamaica, many students are still left behind in the educational system, with only 30% of them nationally attaining an acceptable grade 1, a grade between 1 and 3 in CSEC mathematics. And that is factual, right? Consequently, many educational institutions are actively seeking ways to improve students' academic performance through innovative practices and the use of technology. So to stay afloat, however, and to move along with our educational competitors globally, Exeter Community College has invested in EducaSoft since 2013 to attempt new strategies which utilize online teaching in various mathematics courses. And of course, I was saying to them that this was evident in COVID-19 through all schools. Though all schools have returned to the face-to-face modality, the gains made through the pandemic results of few schools still utilizing a blended approach. With the ease of the internet accessibility across the island and the dependency of many students have on the computer-aided instruments, such as smartphones and tablets, many students do internet searches and class assignments in preparation for examination with the technology. Right. The influence of the use of these innovative computer-aided tools afford additional ways to facilitate the teaching and learning experience. So this is something that I had to write in order to send off to the University Council of Jamaica as we are seeking or institutional accreditation. And I say this to say to you that you will be required in your places of work to do some statistical reporting and research that you have to do the stuff. Now, the data that I have received here, these are some of the grades for the pass rate for 2021 to 2022, semesters 2 and 3, for the foundation courses. So I have 2 groups of foundation 1 I have 4 groups of foundation 2, and I have 1 group of foundation 3. So as you can see, percent of student passing, as you can see, the pass rates don't look that bad, except for foundation concept 2 in group 2, where we had a 44%. No, not true. And group 4, where we had a 43%, right? So we're seeing that the best results obtained would have been, well, say foundation concept 2, group 3, foundation concept 3, foundation concept 1, group 1, and I can say foundation concept 1, foundation concept 2, group 1, right? So these are the combined grades you see for the pass rate for the academic year. And then now I also looked at, so what I did, so these are the raw scores. These are the raw scores for the different groups. So what I would have done is to combine it. So if you look at the data, and this is what I want you to be able to do. So that's why I'm showing you this research. So if you look at foundation concept 1, so no student got an A, so I didn't have an A right here. 1 student got an A minus, I put the A minus here. So forth and so on. So what we can do to see that is the same set of data is that for foundation concept 1, 26 and 22 is 48. And that's why I get this 48 here. All right, because I combined the data. See, combined grades. And for foundation concept 2, 20 plus 18 is 38. 38 and 7 is going to be 45, and that is going to be 52. That's why I got the 52 here. And foundation concept 3 was 25, right? So I showed you the raw data per group, and then what I did was to combine the scores now, because it made it so much easier to do the reporting. Are you following me?
Yes, sir. Clear.
Yes, sir.
All right, good job.
Sure, it
So-
would kind of look like the cumulative.
Very good, excellent.
Got it.
Yeah, excellent. The same thing that we did with our tables. Yeah, man. So when I did this now, and when I combine it, so when I looked at the raw score, I recognized the foundation concept 2. In one sense, I got a 73% pass rate, but in another sense, I got a 68 pass rate. Overall, the pass rate is a 70.8. All right. Of course, the only one that remained as is up here is a 72, which because I just had 1 group. And look at what is happening. So because in group 1 had a 70% pass rate, group 3 had a 71% pass rate, but groups 2 and 4 had 43 and 44 pass rate. So when I average all of those, I'm getting a 57.7 pass rate. All right. So the average pass rate of the foundational courses amounted to about 66%. The truth of the matter is that is 2/3 of the population. Not bad. Could it be better? Absolutely. All right, absolutely. So now, what I did right here, my correlation coefficient is this formulation. That's the formula I use for the correlation coefficient. It looks ugly, but as we go along, and maybe this is why Mikey just said it looks like they what it is that we've done before, because yes, you're going to be finding sums of different things, and you're going to be multiplying your x's and your y's, and you're going to be multiplying. It's only x's and y's you're going to be dealing with, as a matter of fact. And we have end up to find square roots, and we end up with n, which is going to be the number of different things that we use, and so forth and so on. So what I did was to use the correlation coefficient to calculate the total time and grade that student would have gotten, which gave me R, my correlation coefficient, to be a 0.43. And my tutorial time and grade, I got a negative 0.03. And assessment time and grade, I got a 0.41. Really and truly, these don't have any meaning to you just yet, but I will explain to you in a few what is happening. So what I did, and again, you see I'm using up the statistics. So what I'm doing, what is this, a histogram or a bar graph? Which is this, a histogram or a bar graph?
Sir, bar graph?
Bar graph.
It's a bar graph, right? So you see I'm using up my my techniques in statistics, how to do up my reports. So what I did was to do a little chart, because really and truly, who has time, as I told you before, who has time to go through and look at these data and make your eyes them get dazzled and look at the number of students who, total number of students who sat Foundation Concept 1 at 48, and then look at the student pass rate at all of those stuff. Nobody has time to do that. When it is that you can glance, I mean, the raw data is important, don't get me wrong, but persons who are not mathematically inclined would definitely be running for Foundation Concept 1, 2 and 3, and looking at the stuff, and they can say, I see. So Foundation Concept 1 and 3 almost had the same pass rate. One was 70%, 70, well, it's 70 a little bit, but we can call it 70%. And one was slightly above 70%. Clearly, Foundation Concept 2 is what is of concern. So as a researcher, I can pass this information on to my lecturers to say, you know what? The truth of the matter is, interesting. I should really be presenting this at our conference soon enough, because this is something that I should talk about. Anyhow, really and truly, what is happening is that the Foundation Concept 2 has a low pass rate, very low pass rate. When I hover over it, it is telling me that my value is 57%. When I look at this, it's telling me that my value is 72, and this is 70.8, 70.5, supposed to be 70.8, 70.5. Yeah, it's supposed to be 70.8. Anyhow, then now I'm going to analyze the data, and this is where you are going to be required to go. See, I get about 1, 2, 3 paragraphs out of this analysis. Let me show you the analysis. There's something here. So I want you to think of this 0.43, this negative 0.03, and this 0.41. Hear me out now. So the analysis of the data, I said, the correlation coefficient indicated in table 3 for the total time and grade R equals 0.43. So the correlation coefficient is denoted by R. See here, R is equal to this formulation, all right? So R is 0.43, here what it says, shows a fairly moderate positive relationship between the variables, right? So had it been closer to +1, it would have shown a strong positive relationship, right? But because it's almost 0.5, halfway between, do you agree that it's almost 0.5 at 0.43?
Yes, sir. It's
Yeah,
almost
man.
0.5.
Right. So, right. So this is why I'm using the terminologies. This is why I'm using terminology. And hear what I said. It shows a fairly moderate positive relationship between the variables. All right. This suggests that if the total time spent by the students increases, then grade by them would also increase, because this is comparing the total time that the students spent on their activities on Educasoft and the grades that they would have received. So if one is increased, and because it's a linear relationship and it's a positive relationship, if one is increased, it means that the other one is going to increase. So if the students had spent more time on their Educasoft pieces, therefore the grade that they would have received would have gone all the way up. They would have gotten a higher grade. So what am I saying to you? If you spend a lot of time on your Educasoft pieces, the grades that you will get on your Educasoft piece will increase. That's what the research is suggesting. When I calculate the stuff, that's what it is suggesting. Half a second, please. All right. So, so this is what is going to happen now. So hear me out. Continuing. So it suggests that if the total time spent by the student increases, then grades will also increase. The students' grade will also increase. Hear me out now. The other one had a correlation coefficient of negative 0.03. Hear what I say about that? It shows an almost perfect negative relationship between the variables. Why almost perfect negative? Because it's almost 0.00. Talk truth. Hello, somebody?
Yes, sir. Yes,
Yes,
sir.
sir.
Yeah, man. Right. So it shows an almost perfect negative relationship between the variables. Here what it suggests. This suggests that if the tutorial time spent, because what was happening here is the tutorial time versus the grade that the students would have received. Tutorial time versus grade that students would receive. So what it is saying is that it shows an almost, it suggests that if the total time spent by the student increases, then the grade would decrease. But sir, up here, so you say, if the time increase, the grade would increase. But down here, so you say, if one increase, the other one decrease. Why? Think about it. Up here, I say, it shows a fairly moderate positive relationship. This suggests that if the total time spent by the student increases, then the grade received by them would also increase. So one is dependent upon the other. So if I spend more time, that means my grade will go up. But in this year case, I say it suggests that if the tutorial time spent by the students increases, then the grade received by them would decrease. Why would I say something like that? Why I think that was something that was truthful or plausible. Look at
Well, maybe it's a case where they just on it, but they're not really paying attention to what they are supposed to be doing. They just on it because it's a requirement for them to be on it.
well, that would be the explanation there, so but I'm saying, why would
They
I say
didn't
that
have
is
time
no,
to
look at the
think.
value of R. Look at the value of R. You recognize the first one was positive
Yes, sir.
and the other
And
one
then
is
this one is
negative.
negative.
Yeah. So the negative relationship is saying that when one increases, the other one is going to decrease. So it says here,
Also, you
this
continue move to the negative with it increase.
right. So
Oh,
so what it so what it is saying is that this suggests that I have this annoying cough. It's a dry cough and it's just really very annoying. Anyhow, forgive me here. Sometimes I can't find the mute button in time to mute. It says, so it suggests that if the tutorial time spent by the students increases, then the grade received by them will decrease. And this is my reason now. This is so because students were not completing their weekly assessments in a timely manner. You see what I'm saying? So it's just like how you guys know, like how you guys know, kind of pussyfooting around completing your assessments. I'm not completing assessments in a timely manner. When I do a research on the grades that you would have received, I'm going to end up getting a negative grade because it means that you are not completing your work in a timely manner. Following me?
yep, yes, sir.
All right. If they were to increase tutorial time, then they will not be able to complete the assessments and or receive a passing grade. So if they were to increase the tutorial time, then they will not be able to complete the assessment. Meaning, because they never do so much work, if them go do the tutorial now, it'll go eat up more of the time and they're not going to be able to complete the work. You see what I'm saying? So at that point in time, students are just only now forced to just go complete the assessments. You follow me?
Yep.
Yes, sir.
So students are assigned homework, practice quiz and quiz each week on the platform. Analysis of the data revealed that almost all the students of FCM3 were behind for the duration of the semester. Students were consistently reminded of their tardiness, but they complained that they are competing with work. Extra time was allotted for them to complete all outstanding pieces. The correlation coefficient for assessment time and grade R equals 0.41. R equals 0.41. R equals 0.41. It's suggesting a fairly moderate positive relationship again So it says, in this here case, because it's showing a fairly positive relationship again, in this here case, it is also suggesting that if one variable increases, the other variable is also going to increase. If one variable increases, that means that the other variable by extension is also going to increase. All right. So that's how we utilize this aspect of the this aspect of the, we call it the correlation coefficient, to report on things using our correlation coefficient. It's a very useful tool, very, very useful tool. A tool that is used right across in order to be able to complete lots of reports. Am I making any sense though?
Yes, sir.
All right. Now, I went on to say that the data displayed in the table 1 shows that there are other five of the 7 groups of students that use Educasoft had a pass rate of above 68%. The grades students received in using the Educasoft platform were much higher than those received in the traditional face-to-face method of teaching, because students were more likely to do more continuous assessment in an e-learning environment. And this was supported by the fact that 2/3, 66% of all the FCM students obtained a grade C plus or higher. And of course, we look at the table. So, I was able to draw some conclusions that faculty needs to monitor more closely the weekly completion of assessments, that they will also be encouraged to upload class recordings or otherwise to the platform to centralize the information. I also suggested that they could also activate the discussion forum on the platform to encourage greater collaboration among the groups, and to send congratulatory class announcements to those students who are on track, to automate reminders to complete assessment, outstanding assessments, and to activate more tutorial sessions. Now, when I did this report, and you see this report was about 5 pages. When I did this report, I got great reviews of it, because what it did, it encapsulates and it summarizes the students' performance over an academic year, looking at Foundation Concept 1, 2, and 3. Right? It summarizes the students' academic performance over a 1-year period, looking at Foundation Concept 1, 2, and 3. Information such as this is very good for me as a teacher, so that I can know and to share for the faculty, to say, here the plan. This when you give the students them work on Educasoft, but just give them the work on Educasoft. Go remind them, say them not do the work on Educasoft. You gotta do this stuff. And all of this was gained from doing my correlation coefficient, just the analysis of the data and the calculations that were done. I got that information and I was able to draw that conclusion. Fair enough?
Fair.
All right, good. So that's what that's one thing. All right. So with that said, now allow me to going back to our stuff, because we are now going to do our calculation. See, all of the formulation here with all of the formulation that you saw earlier in that report that I have. Of course, I won't be able to finish all of this today. So this is my R, the correlation coefficient. So that formula that you saw that I highlighted in the document, this is it that I would have highlighted for you. All right, so let us see how best we can get through even the first part of it. So we're going to be required to look at a line of best fit. So sometimes they will give you the data. They'll give you the data and they will ask you to plot the data. So you're going to get a graph paper. You're going to put your X and Y axis. You're going to put you're going to calibrate the graph paper in a way. Then you're going to plot the points on the graph paper. You may find the points clustering, or you may find the points scattering. But at some point in time, you need to do a line of best fit. A line of best fit is one that is drawn where you have almost an equal number of dots on either side of that line. So the line of best fit is not a line that is going to be a random line that you just draw. And I am actually trying to plug in my tablet to demonstrate what a line of best fit looks like. I'm sorry. I'm trying to I'm trying to show you here what a line of best fit looks like, but this system does not want me to be great. It is doing its own thing. So,
Sir, sharing something new?
oh, cockroach. Yeah, you're right. Thank you, sir, for telling me that, because I am. Are you seeing my new share?
Yes, sir.
No, that's the
All
new
right.
share?
Yeah, this is
Yes.
a new share. All right. So, all right. So the line of best fit. All right. Suppose you have some points. Let me just put this down and hopefully it don't shift. Suppose you have some points and you want to have the line of best fit. Now, my line of best fit could be anything like this. Let me put some color to this thing here. My line of best fit, I could have some points, some dots. Can you see those?
Yes, sir.
All right. So I couldn't put a line like this and call it my line of best fit. That's not a line of best fit. The line of best fit is going to be a line that when it is drawn, if I count here, we have 1, 2, 3, 4, 5, 6, 7, 8. No, 7. Right? If I count it down here, we're gonna have 1, 2, 3, 4, 5, 6, 7, 8. So I have 7 points up top and I have 8 points down the bottom here. Right? So if I pull this line down a little more, so maybe I'm able to get 7 on one line and 7 on the other line. So let me try putting that line again. One, 2, 3, 4, 5, 6. I'm not counting those two because those were on the line. So this one is not on the line. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Now I have 6 and I have 7, right? So every time I look at it, I have one a piece off. So for me, this is going to be my line of best fit. Can you understand what I'm talking about there? So it's a line that is going to be drawn, that is going to be dividing my data in such a way that it goes right through the data set. Now that method that I just used a while ago is by eye. So if you look there, it says we can place the line by eye. So we're going to try to have the line as close as possible to all the points and a similar number of points above and below the line of best fit. Can you follow me?
Yes, sir.
I don't hear the rest of your answer though.
Yes, yes, sir.
Yes, sir. Fine.
All right. So Sir, will we be required to do by eye line of best fit? No, because we have a calculations method. But sometimes when you get it, sometimes what they could give you is they could give you some data that is drawn on that are plotted on the some points plotted on the graph paper. And they could ask you to do the line of best fit. And when you're doing that line of best fit, you're going to draw the line by eyeing it, just looking at it and say, hey, this look like this. And just eyeing the line. And when you do that, then you're going to put a line of best fit. And for those of you who remember anything from physics, or even math, you know, we can draw or rise or run. So we can calculate the slope to see if the line slopes upwards or if the line slopes downwards. And lots of mathematics inside of this. Lots of mathematics. All right. Now, however, for better accuracy, let us see how to calculate this line using the least square regression. So I can eye it by just drawing a line like I did up here in purple. Like I did there. Or I can go ahead and do my line of best fit by calculating it using a least squared regression method. Now, what is this line? How do I do this? How do I go about doing this? What it says here is that our aim is to calculate the value of m, which is the slope, and b, which is the y-intercept in the equation of the line. Remember, the equation of a line is given in the form y equals mx plus c. Talk through. Anybody remember that?
Yes, sir.
Yes,
Yeah,
sir.
man.
Remember.
Yep.
But for big school, we're going to call it y equals mx plus b. Same difference. Same difference. And the same thing, all we're doing is just using a different variable. Same thing. M is going to be my slope, and b is going to be my y-intercept. So what is the y-intercept again? The y-intercept is what cuts the y-axis. So for the y-intercept, x is going to be equal to 0 every single time. Why is it equal to 0, sir? Because it is at that point that it cuts the y-axis. It is at that point that it cuts the y-axis. So it's going to be equal to 0. So it's going to be equal to 0 because it cuts the y-axis. So remember, is it this group? Is it your class? No, not your class, you know. It's my calculus class. So let me just spend some time on this one here, since it's not your class. So once we talk about the y-intercept, it means that x is equal to 0. The other variable is going to be equal to 0. There's a y-intercept. Anywhere in the function you see x, you're going to put equal 0. If they ask you, on the other hand, for the x-intercept, which one are you going to put equal 0?
The Y.
Very good.
What?
So you recognize it's the opposite one, we're going to put equal 0. So if them ask us for y, that means is x going to be equal to 0. If them ask us for x, that means y going to be equal to 0. There is no way they can answer for the y-intercept and you put y equals 0. That not cut it. That not make sense. So it is the other variable that is going to be equal to 0. It's the other variable that is going to be equal to 0. I want you to know that you're following me. I don't want to just be teaching. I want to get some feedback. Are you understanding what is happening here, guys?
Yes, sir. Following so far.
Yeah, man. It really not bad. This is a nice part. And guess what? Our secret. You see everything we've done so far
Past paper.
on a past paper. Yes, you're correct. You're correct. And we're going to the exam and we're going to answer them questions them there. Because This is where we're going to pick up lots of marks. We're going to pick up lots of marks. Just answering these questions. Lots of marks. All right. Now, having explained the whole concept of the x-intercept and the y-intercept, allow me now to show you y equals mx plus b, y equals mx plus b, y and x are just really my coordinates. Y and x are really my coordinates. So my y is telling me how far up, and my x is saying to me how far along. And the m is really the slope, how steep it is. Sir, how far up? How far along? Thanks for asking me. Y2, Y1, X2, X1. SLOPE. This is my rise. This is my run. How far up? How far along? How far up and how far along? All right. Now, it's a right about now. If me could have just afford, yeah, I'll drive, go down on Negril right about now, like right at this current moment as we speak. I could be driving down, well, I could be driven down while I'm teaching you. But I know that when I'm finished, I'm going to get to a hotel down there that I'm going to just relax for tomorrow, the day after tomorrow, and the day after that. Get a good 3 days of the sleep and just get lazy and then come back refreshed for Monday morning. All right? Hear me out. When you reach on the Edward Siaga Highway and you're cutting through Monique, you will climb one hill. You're climbing a hill. And they will say to you, say, boy, if you're driving a heavy vehicle, you know, stay to the left. So in the event that you develop any mechanical problems, you know, block the road. That's the slope that I'm climbing. So sometimes you'll go and you see on the hill something like 8%, or you may see something that says 6%. It is telling you how steep it is. Sir, all the man them know it. Them calculate it. Don't you know if you calculate dip and strike? So the man them calculate it. And them cut through the hill, you know. Those are mountains. There are mountains, there are hills. And what the man them do? The man them go through and cut through it. Now, unfortunately, sometimes when they cut through it, they did not tie back the exposed surface of bedrock. So the bedrock starts to weather. And because them the shortcut to something, it begins to weather, and that's where you have the land slippage. Because some of the exposure there is shale, which is very brittle. It's not all of it that is limestone. The limestone version of it stand up strong, right? So what they should do, like for those of you who live in Portmore, and just as you go under the bridge line, you don't go through a bridge again. When you go through the toll booth and you're going to the left, like you went on to back road, that overhead.
Port Henderson Road, man.
Port Henderson, sorry, I said back road, forgive me. Port Henderson Road. Oh, dear me. When you went on to Port Henderson Road there, so there's an overhead, all right? Now, that overhead, you will see them have, what they did there was to spray liquid grass. They spray liquid grass. And sometimes for these exposure, you may wonder, sir, how all of this coming to math now? Because it is math. So them spray liquid grass on the stuff, and liquid grass is just grass seed with water and fertilizer. And them spray it on the stuff. They may put a little dirt on it, something so at least it get root. And what happens now is that the grass is going to grow. So what happens is that when the grass grows and it covers the earth, it binds the soil together. So the soil will not move. Does that make sense?
Yes, sir.
Plenty
Yeah, man.
sense.
Yeah, man. So that's how they treat with slopes on different inclines, right? On different inclines. Point of information, I had a meeting today, and we are going to, well, Dan will be leaving, but of course we're going to call her back. We are going to be celebrating our 50th year come September of 2024. And one of the things that I said in the meeting is that the School of STEM is going to be undertaking a project. I hear my project. My project is going to be that space between blocks A and B. You know, that little place where them have the little water fountain and them have the annex around there, so when people sit up on the little bench them. Yeah. When next you come on the campus, you look at that poinsettia tree. Poinciana tree, not poinsettia. The poinciana tree there. The root structure is being exposed to a lot of the elements. Rain, sun, foot, everything. So at some point in time, those root systems are going to die. The root systems are going to die. It's not prone to termites, prone to a whole lot of stuff. So inevitably, the tree will die. Inevitably, the tree will die. So in the presentation today that I made, I said to them that the School of STEM is going to be undertaking something where it is that we can build a groin. We build a groin so it is that when it rains, we don't have that mass movement of the soil anymore to wash away the soil from there. Because every time it rains and we have a heavy shower of rain, we have the soil moving and more root structure is being exposed. So we are going to build a groin so that it preserves the soil from moving any further, and that we can beautify that area, that area of the stuff. So it is that it becomes a little bit lush and more environmentally friendly, right? It can now, we can put in a bird bath. Well, we have something similar there already. So it can attract more birds to come there to feed and to bathe, and you know, we can buy feeding and we can put in there maybe once a day. So at least, you know, we attract more of these birds to form some natural habitats there. You know, once they have food there, they can form bird nests and the whole works. And the whole works, right? What am I talking about? The slope. So
Right.
every time it
Sound like,
rains, say it
sorry,
again?
sound like you set up on climate garden.
Same here, so. Same here, so. So every time it rains, the soil is moving down here. This is what the slope looks like. But my Y is talking about how far up. This is my Y-axis. Talk to, oh, this is the Y-axis.
Yeah, that's it.
And this is the X-axis, don't?
Yeah.
Yeah. So the Y-axis is talking about how far up do I go? So you see here, how far up and how far along the X-axis am I going? And of course, M is my slope. My slope is M. So that's what this whole business of the line is talking about. Y equals mx plus b. Y equals mx plus b. All of this here. You know what Y is? How far up? M is going to be the slope. X is how far along. And B is going to be the Y-intercept. B is the Y-intercept. Sir, what is the Y-intercept again? Anywhere the graph cuts the Y-axis is the Y-intercept. Anywhere it cuts the Y-axis is known as the Y-intercept. All right? Let's continue. And then now, see here, Y-intercept. I didn't recognize that I have it here, but yeah. So these are my steps. It's so nice. I am going, I've itemized the steps for you. There are 5, okay. There are 5 steps. and I've itemized the steps for you so that you know exactly what to do when you do the calculation. Numero uno. For each xy point, you're going to calculate x squared and you're going to calculate y. Sir, or you get x squared. See, you have x right here, so. See, you have y right here, so. For each of these points, you're going to square the x to get your x squared. And the other one, you get multiply x by y to get your xy. Then you're going to sum, forgive me. Then you're going to sum all your x, your y, and your x squared, and your y squared. So what do you mean? You remember, you can have all the x's, you know. You can have all the y's. Then you can find the x squared. And after you find x squared, you can find x times y. So you're going to sum all of them. What do you mean by sum, sir? You can add them up. And that's going to give you the sum of x, comma, the sum of y, comma, the sum of x squared, comma, the sum of xy. Then you're going to use that to calculate the slope. And that's the formula for the slope. M, the slope, is going to be equal to n, which is the number of points that you have. The number of points that you have times the sum of xy minus the sum of x times the sum of y, all over the number of points times the sum of x squared minus the sum of x all squared. Sir, that look hard. And yes, it looked hard because it's seen for the first time. But I promise you that as you go through your questions and you put this formulation to memory, you can regurgitate this quick and fast. Quick and fast. Easy 1, 2, 3. Quick and fast. All right? So again, m is going to be equal to n times xy, the sum of xy, minus the sum of x times the sum of y, all over n again, times the sum of x squared, minus the sum of x all squared. And then note it. So that's how you calculate m. To calculate b, the intercept, b is going to be equal to the sum of y minus m. That means you have to do this part first, sir. Yes. It is going to be this m, the gradient, the slope, times the sum of x all over the number of points that you have. And then you're going to put it into this formulation, y equals mx plus b. So technically, it's 2 calculations you're going to do. This one here and this one here, then we substitute it into this one here. All right, let's go again. So for each of your xy values, and I'm going to do a question with you, don't worry. So for each of the xy values that you get, for each of the xy values again, you can calculate this, you can calculate x squared. You're going to do another column where you're going to square all the x values. And you're going to do another column where you're going to multiply your x by your y. So right there, and then you're going to have 4 columns. A column with x, a column with y, a column with x squared, and a column with xy. Tell me, say, following what I'm saying.
Yes, sir.
Yes, sir. Following so far.
Good.
Before you move,
And-
sir.
Go ahead, Papa.
So, when they say each point, so you're gonna have like several x points, several y points,
Yeah, man.
and when you're squaring it, you're gonna square each of those x points to get the x square.
Yeah, man.
Oh,
You remember the data that I showed you?
yeah,
You remember I had A minus, B plus,
yeah.
B minus, C plus, C
Straight down to
minus.
F. Mhm.
Right. So it's all of those. So the value that I get for A is going to go through all of this.
Oh,
But I get for
yeah.
B. Yeah.
Okay.
So you have to go do that. So we are
I
very
wonder if I,
mindful.
I wonder if
It's
I
a whole
work
heap of
it out.
calculation. Yes,
Yeah.
yes. So we're mindful that when we're giving you and that's why I had to group the data. because it would have been way too much for me to go ahead and do the calculation. And I still got the results that I wanted. And the results that I got made lots of sense. All right? All right, so let's go. And then now, you're finding your x squared and you're finding your xy. When you do that, all you're going to do is to go and add up all of the x's, add up all your y's. Half a second, please. And then you're going to find the sum of x, you're finding the sum of y, you're finding the sum of x squared, and you're finding the sum of xy. Once you find that, all you need to do now is to calculate m. What is m again, sir? Thank you. It's going to be n, the number of points that you worked with, times xy, the sum of xy, minus the sum of x times the sum of y, all over n again, times the sum of x squared, minus the sum of x, all squared. That will give you the value of n, your slope. To calculate b, the y-intercept, you're going to say the sum of y minus the slope times the sum of x, all over n, the number of points. And once you get your b value, you substitute it in this formula and you're good to go. You're good to go. You know what? Let me do sometimes for the exam for the multiple choice. Let me give you some values, some data. Let me give you a table. Or they may say, you know what? We're not going to put them a table, I'm going to give them a value for the sum of y, a value for the sum of x, a value for x squared, and a value for xy. And then ask you to calculate the least squared regression. You already have the sum, so you don't have to add up nothing. You just substitute into the formula there. All right? Having gone through this 2 times, let us look at an example. So Wayne found out how many hours of sunshine versus how many ice creams were sold at the, sorry, at the shop from Monday to Friday. So he's a small businessman. And him say, boy, there were 2 hours of sunshine, I'm only sell 4 ice cream. 3 hours of sunshine, I'm sell 5. 5 hours of sunshine, I'm sell 7. Whoa. It look like when we have more sunshine, I'm gonna sell more ice cream. Because when I 7, we sell 10. And when I 9, we sell 15. Now, we need to calculate the least squared regression. See here? The least squared regression, we need to calculate the least squared regression. So we're going to put our stuff in that table. So what we're going to do, remember, 2 and 4 go together because 2 is my x and 4 is my y. 3 and 5 married, 5 and 7 married, 7 and 10 married, 9 and 15 married. Watch me. So you notice what I've done? I've extended this table like so. The table says must calculate x squared. Let us check. These two columns were given, true or false?
True.
Yeah, they were given already. Yeah.
2 squares give me 4, don't?
Yes, sir.
3 squares give me 9.
9,
5 squares give me 25.
25.
7 squares give me 49.
Mm.
And 9 squares give me 81, don't it?
Yes, sir.
Mhm.
Yes,
That
sir.
is my x squared. Work with me now. It's a x times y. 2 times 4 are 8.
Yep.
Yes.
3 times 5 15.
Yes,
7
sir.
times 5 is 35. 10 times 7 is 70. And 9 times 15 sounds like 135.
Yes, sir.
Tell me if that hard.
No, sir, not so
All right,
far.
No.
good.
If you have a
No hard.
calculator, you're good, man.
All right. So guess what now? Let me see if you're following what is happening. Tell me what is going to be my next step then. What will be my next step?
You're supposed to
The
do the
sum of
sum of x, the
Very
sum of
good.
y, the
sum of
Very,
sum of
y.
very, very good. Yeah. So we say now, we say bright. We're going to sum them now. So we write by the table. Remember, now, I'm doing these things in steps. So you don't have to write the table 2 times and 3 times and 4 times. I am only doing it in steps to show you, eh? So all of this table, come back, all me doing the same. 2 plus 3 is 5 plus 5 is 10. 10 plus 9 is 19 plus 6 is 26. So I get the sum of x to be 26. I'm going to say 10 and 15, 25, 25 and 5, 30, 30 and 7, 37, and this is 41. Boom. Then now, I say 81 and 9 and 90, 90 and boom, try on 168. And then we do all of that and we get 263. So I find my sum. So I have oh, but I don't have n. Anybody know the value of n?
Sir, M is a formula.
Yeah, but n, what is n? N has a number. What is n?
and not supposed to be the total number of points or something.
And how many points we have?
2, 4, 6, yeah, 10.
How
20.
many points?
5.
5 points. Remember, so the
5?
points I'm married now.
Oh, yeah, they're
Remember the
married.
points I'm married now. So a point is x and y. So x and y give me 1 point. So the 20 I'm married and give me 1 point. So we're gonna have 5 points. All right. So good. Cool. So now we're gonna put it into the formulation. Remember, the hardest part of this is for you to know your the formula. That's the hardest part of this calculation. May not ask you. May I tell you? And if you know the formula, it is not going to be difficult at all. All right. So see here, and it's 5. So all I'm doing now, look, the sum of xy, see xy here, the sum of xy 263. 5 times 263 minus the sum of x, see the sum of x here is 26, times the sum of y, 41. See? 26 times 41. All right. All over n, which is 5, the sum of x squared. Uh-oh. See? N times 168 minus the sum of x all squared. So this is going to become 26 squared. Look at that and tell me if you agree. Also, what I want you to do is to take your own calculators now and to work out and see if you get the same answer like me. 5 times 263, see if you get 1315, so forth and so on, and see if you get your m to be 1.5183. I give you 3 minutes to do. Just just check this one for me. Start from here, start from there, and check to see if you get these other 3 lines. I'm going to rest my voice for 3 minutes.
Yes, sir.
Yes, sir.
Good job. Mikey, how you stay?
So, may I work them?
And then you don't talk to me from there, you know.
Mm. Mhm. 1066, and then the bottom would be your 40. Or 26. Yeah, yeah, I got them.
Yes, sir, I got it.
Mhm.
All right. So we calculated our M to be 1.5183. Now, in the last 10 minutes or so of the class, we need to calculate the value of B. And that's our other step. Step B now, this is the second to last step, is to calculate the value of B. Now remember, to calculate B is going to be the sum of Y minus M times the sum of X all over N. So what I did here was just to recall the data right here. So I don't have to be flipping back and forth, right? So all we're doing here now is substituting the data here into the formulation here. So it's the sum of Y, 26, lie, 41, minus M, M is 1.5183. See it here, so? M is 1.5183 times the sum of X. The sum of X is 26. See it right here, so? All over N. N is 5. N is a number of points. Remember, point has an X value and a Y value together, married together. A point has an X value and a Y value married together. One can't stand without the other. Let me tell you how important it is. And you know, the truth is, while I was studying geography in school, it really never dawned upon me. Because you know, sometimes really and truly go class and you can't relate what it is that you're doing in class to the real world. And has it ever happened to you before? You just go to class and just go learn something, but you can't
You
envision
don't
it.
see how it applied to the real world.
Yeah. And that's why every time I teach, sometimes I stop and give the stories, because my stories helped me when I was going to school. So I can relate to it. So now when I come and I ask you and say, oh, sir, this say, when you're doing this, okay, yeah, I can relate it to the real. And this is why I show you a report before the start of the class. So the research that I showed you is to show you know how it is that I went ahead and calculated the slope and B, and the information that I use to generate a report to submit to the institution. Very important. Very, very, very important that you are able to make connections. So when I was doing geo and talking about coordinates and them something there, it never dawned upon me. But they just know say the X and the Y have to go together. Me just couldn't relate it. And because I was always a good math student, me couldn't relate that. Why Sir Shandy must go? Because that's what them say. You know, when it became very real to me was when you know, you're traveling and especially in New York, 46th and Penn State and 3rd Avenue. And I said, Penn State and 3rd Avenue? You remember now, you know, you're gonna come off of Penn State, you know, right? That's at the train line. So when you're upon the train and they said the next stop is Penn State, you come off of Penn State. So it's when you come off there, so you're gonna walk until you reach 3rd Avenue because the US is built in blocks. So when you walk to the 3rd Avenue now, you're at your cardinal point, your intersection. And when you reach right there, so them say, and when you reach there, so you're going upon this avenue, whatever the situation is, I meet you right there. So if you can follow basic directions, you can't lose. You can't lose. Real talk. So this is what it is in the mathematics. When you're talking about your point, it's an X value and a y value. It's your latitude and your longitude that comes together that gives you the point. So when we're tracking, when I was studying and we had to track on the Sapphire Hill scale, when we plot in the path of a hurricane, we have to know the latitude and longitude. I said, okay, all right, yes. The wind speed pick up now, and it's way near, So okay, yeah. I mean, it upgrade now to a category 5. The wind speed is this. This is the latitude. This is the longitude. All right, fine. And we start to map and say, whoa, this hurricane is moving in a rapid, haphazard fashion. So it's not like when they have these computer models that you can do now. When they go to school, they have to do it manually. You have to literally sit down and plot it to get the data. You get the reading. So, and this is what the Met Office does actually too, So when the Met Office gets their readings, so they have different stations across the country. And you may call me and say, Shand, are you up what water belt? I say, yeah. What is the temperature up there now? And I go and I read the temperature. I say, boy, it's 26 degrees Fahrenheit, And you get that and say, what is this? What is that? And I give it a read. So I'm getting actual readings. And the actual readings are going to be then mapped on the stuff so you can actually see what is happening. That's how it goes. So this is what it is that is done. When I substitute all of that, I want you to do that for me now because I want to make sure that you understand how to get it. Put in your B, your data, and tell me if you get B to be equal to 0.30484.
Yes, sir, I get that.
Good job. Good job.
Yes, sir, I got it.
Good job. Waiting on the rest of you.
Got it.
Good job. Excellent. Now, the final step, and we reach the end of the class, is that we're going to substitute it now into y equal. Sorry. We're going to substitute it now into y equals mx plus b. So y is just y. Y equals m. Remember what m is? M is 1.153, 1.5183. See here? All it is just in the assembly equation. So m is 1.5183x minus what my b is. Sorry, that's a minus plus my b. I'm happy that I said minus though, because sometimes when you calculate b is going to be a negative value. So this sign here, any sign that b gives you is going to be the sign that is right here. And this is going to be my least squared regression. That's how we calculate your least squared regression. Was that hard?
Nope. No, sir.
No,
I
sir.
don't think so either. All right. So I'm going to end it here. I'll just take your questions. I will share this document with you. Yeah, I'll share it now with you. So that you can have a look at it. I may give you I'll give you that explanation next class.
Sir.
Yes, Papa.
All right. So the equation is y equal mx plus b.
Mhm.
I see m
Mhm.
1.5183.
Mhm.
I'm not seeing the x.
See the X right here, man.
So is we should, so the value for x would be what?
Aha. So we're not, remember, x is a variable. X is a variable.
Also, you insert any one of the x.
All right. I don't know. I really don't. I really can't answer that question. I'm going to ask you to do it for me. I'm going to ask you to do it for me. So if you have, do this for me, please, Mikey. All of you do this for me, please. 1.5183. Put in your make sure you clear your calculators. Put in 1.5183 times it by 2. Thanks. Times it by 2. And then add 0.305 to it and tell me what you get. Or 0.30484, whichever one you want to use.
Sir, I get 3.0671.
3.0671?
Yeah, when I add the 0.305.
No, add 0.30484 to it from it, please. Forgive me. I'm going to change this. I shouldn't run it off. I'm going to change this. Add a 0.30484 to it. Then what we get.
$3.3414.
All right. You see why I have the 3.34 here now, Mikey?
Oh.
Right. So to answer your question, Mikey, yeah, man, you're not seeing the x because the x values here is a variable. The x values are my independent variable. So when I substitute my independent variable inside of it, these are the dependent variable. So y is a dependent variable. Y depends on the value of x. So when I substitute my x equals 2 into this, Mikey, I'm going to get 3.34. When I substitute x equals 3, I'm going to get 0.486 or 4.86. When I substitute 5, I'm going to get 7.89. When I substitute 7, I'm going to get 10.93. And when I substitute 9, I'll get 13.97. Because this value here now are all going to represent my y value. They're going to represent my y value. And guess what? You will say to me, but sir, the y value here is supposed to be 4. Why I only get 3.34? Yeah, man, that's why the error is 0.66. So when I add 0.34 to 0.66, you will get back 4. Talk truth.
But why is it in the negative?
Because I didn't reach a value of 4. I'm short. So this one here, the y value is supposed to be 5. I only get 4.86. That means I'm short. So that's why I have 0.14. The y value here is supposed to be 7, but we get 7.89. So therefore, we're going to have a positive 0.89 overage. The y value is 10, but we get 10.93. That means I have an overage of 0.93. The y value of 15, but when we work it up, we get 13.97. That means I have 1.03 short. So that's why it's a negative sign here. You follow me?
Yes, sir.
Yeah, man. So I want to show you how it works. So this is how it works. I actually put it in the stuff, and then I can look and see the calculation. So technically what it is saying to you that the calculations are slightly off, but it is correct. It is slightly off, but it is correct.
Oh, sir, so we not really have to do the error part. You're just showing us?
Right, unless it is asked. I was only showing you how it works.
Okay.
Unless it is asked. Right? Normally they don't ask you for that for the question, but I was just showing you how it works. You follow me?
Yes, sir. Following you.
All right. I'm going to end here. I'm going to send you the notes. Students, please I know I would have responded to your message, Paz, and Asia, I don't execute your stuff yet because there I had a face-to-face class this morning and a meeting that overlapped, and the meeting went on from 10 o'clock until almost 2, well, about 1:30. So I really never got the time. So when I responded to you, Paz, I was actually preparing for the meeting. So, you know, give and take a few. I will then respond to you, but there are others of you in the class that have not yet started in anything. And I'm gonna ask you, don't allow the math to pile up on you. Get the work done up and done up quickly. All right?
Yes, sir. We can
All
plan
right,
for
I hope
done
you-
this by
Sir.
next by the middle of next month.
I would think so. Yes, Paz.
No, sir, I was just responding to you when you said don't let the math pile up.
Yeah. Very important. All right. I enjoyed tonight's class, even though my throat gave me a problem. I really hope that you guys learn something and you can, you know, replicate it when the time comes. All right. I am saying goodbye to you now. Have a good one.
Bye, sir.
Same to
Take
you,
care.
sir.
Good night.
Good night.